This video, I'm talking you through the answers to the Edexcel IGCSE paper 1H, so the higher paper from the 3rd of November 2020, my reference number 9. Question 1A. Well, this means A intersection B, so the members which are in both A and in B. So where do A and B overlap? It's these four numbers in the middle. So 2, 4, 6, 12. Now this B dash means not in B. So all the ones that are not in the B football. So that's the 8, 14 and 10 over here. They're not in B, but neither are these over here. So also the 9, 13, 11, 7 and 5. 1C, we're picking at random from all the numbers. So as the numbers go from 1 to 14, we're picking out of 14. So our denominator will be 14. Remember, when you're asked for probability, fractions is always easiest. And then we're looking for the number that are in A, but not in B. So they're in the A football, but not in B. So not these here. So that's just the 8, 10 and 14. So that's three members. So 3 out of 14, 3 over 14. Question 2. So 5 toy cars are made every 12 seconds. So let's scale that up to how many are made in a minute. So 12 fives are 60 seconds in a minute. So if we multiply both of these by 5, we can see that 25 cars are made every minute. Now multiply that by 60, it will give us how many cars are made every hour. So that's 1,500. And as the cars are made for 15 hours per day, if we multiply that by 15, we see that 22,500 cars are made every day. Now, the probability of a single car being faulty is 0.002. So how many cars would you expect to be faulty? Well, it's the 22,500 multiplied by 0.002, giving us 45. Question 3, y equals 7 minus 4x. Well, this is going to be a linear graph, a straight line graph, as we've just got x's and normal numbers. Now, I think given we've got to go from x being minus 2 to 3, and we know it's a straight line, let's just work out the y value when x equals minus 2 as one extreme end of the line, the y value when x equals 3, and then just join those two points together. So when x is minus 2, substituting that into the formula, so 7 minus 4 lots of minus 2. Well, minus 4 times minus 2 is plus 8. 7 plus 8 is 15. So that tells me when x is minus 2, y is 15. So my first coordinate is minus 2, 15. So 2 to the left, 15 up. X marks the spot, the point here in blue. Now, secondly, let's go to the other end of the line when x equals 3. So substituting 3 into the equation, 3 into this, 7 take away 4 lots of 3 is 7 take away 12, which is minus 5. So our second point is 3 minus 5, 3 to the right, 5 down, join them together with a ruler. Question 4. Now we're told the median is 9, so the middle value is 9. Now as we've got an even number of numbers, so we've got 6 numbers, the average of these middle two, the midpoint of these middle two, has to be the median of 9. So what must x be such that 9 is halfway between x and 10? So x has got to be 8. Okay, the median, the halfway between 8 and 10 is 9. So we now know we've got 4, 7, 8 and 10, and we can add those together, okay, in a minute. So we're told that the mean is 11. So when you add all 6 numbers together and divide by 6, you get 11. So therefore the total must be 66. 11 sixes is 66, because 66 divided by 6 would give me my mean of 11. So I know these 6 numbers add up to 66, and I know that 4 of them are 4, 7, 8 and 10. So 66 take away those 4 numbers added together, which is 29. 66 take away 29 is 37. So these two y values together have got to equal 37. So obviously they're both the same value, so halve it to work out what each of them is. Half of 37 is 18.5. 5a, write 5.7 times 10 to the minus 3 as an ordinary number. Now the power is negative, so I know this is going to be a very small number. So as a working, set up lots of zeros to the left-hand side of the 5.7, giving us something to hop over. Now it's to the power of minus 3, so the decimal point is going to do 3 hops. So 1, 2, 3 is going to end up here. So we can see our answer is 0.0057. Similarly for part B, this is going to be a big number. Now with standard form, remember rule number 1, the first number's got to be between 1 and 10. So where would you put the decimal point to have a number between 1 and 10? Well, it's obviously going to be after the 8. So it's going to be 8 times 10 to the something. First number between 1 and 10. Now, how many powers is it going to be? So how many hops do we do with the decimal point? Well, when you've got 800,000, the decimal point is after that. The decimal point's going to end up between the 8 and the first 0. So that's 1, 2, 3, 4, 5 hops of the decimal point. So 8 times 10 to the 5. Now for part C, start off just by working this out using your calculator. So use the fractions button and take advantage of the times 10 to the button at the bottom. So just popping this into your calculator, you will get this as your final answer. You could put it into standard form. You didn't lose any marks, but there was no need to do so. Now for question 6, remember just to think of speed as how far you go in a given period of time. So 28,440 kilometers per hour means you go a distance of 28,440 kilometers in 1 hour. So that's my first line of workings. 28,440 kilometers in 1 hour, which is 60 minutes. Now, because we've got to give our answer in seconds, I'm going to straight away convert to seconds. Now, there are 60 seconds in a minute, so 60 minutes is going to be 60 times 60, which is 3,600 seconds. So we go 28,440 kilometers in 3,600 seconds. So how many seconds would it take us to go 100 kilometers? So we just need to use our proportional skills here. How do we go from row 1 to row 2? What do I multiply this by to get 100? So I've just popped into my calculator 100 divided by 28,440, and that gave me 5/1422. So to go from row 1 to row 2, I multiply by 5/1422. So that's what I multiply the distance by. That's also going to be what I multiply the time by. So 3,600 multiplied by 5/1422 gives me 12.658 ... seconds. So to the nearest second, that's 13 seconds. 7 part A. So start off by multiplying out the left-hand side by expanding the bracket. So 5 times 4 and 5 times minus x. So 5 times 4 is 20. 5 times minus x is minus 5x. Now, I'm then going to choose to gather all my x's on the right-hand side. So I'm going to add 5x to both sides. And that gives me 20 equaling 7 plus 2x minus 3x plus 5x is 2x. I've just repeated that over here. So I've gathered all my x's on the right, so I'm going to gather all my normal numbers on the left. So I'm going to undo this 7 by subtracting 7 from both sides. So 13 equals 2x. How do you undo a times in by 2? You divide by 2, x equals 13/2, or 6.5. 7b. Now factorising means putting the brackets in, and fully means there's going to be more than one component coming outside the bracket. And you'll see here we've actually got 3 components. So just work your way along component by component. So just looking at the normal numbers, what's the highest common factor of 16 and 24? Well, that's 8. What's the highest common factor of m cubed and m squared? Well, that's m squared. And the highest common factor of g cubed and g to the power of 5 is g cubed. So get that on the outside, open up your bracket, and just imagine that first claw. 8m squared g cubed times what would give you 16m cubed g cubed? Well, we needed 2 to get our 8 times 2 is 16, and we need another m to give us m squared times m is the m cubed. We're fine with the g's. Then moving on to the second term, well, we need a plus sign. And then 8 times what will give us 24? Well, that must be 3. We're all okay for the m squared. We've got m squared already. And g cubed times what will give us g to the power of 5? Well, we need a g squared. And close your bracket. And they're easy to check. Just work backwards. Check that this times this gives you this. And this times this gives you this. 7c, factorise this quadratic expression. So we're going to have a pair of brackets. Remember, factorising is putting in the brackets. And when you've got some y squared, some y's and some normal numbers, that's going to be a pair of brackets. Now, the first term in each bracket is going to be y, because that first clause, y times y, would give us the y squared. So the skill is in working out what I call these two magic numbers. So to work these out, what two numbers multiply to be the term on the end, minus 48, but at the same time, which two magic numbers add to be the coefficient of y? So add to be minus 2. So what multiplies to be minus 48 but adds to be minus 2? That's 6 and minus 8. 6 times minus 8 is minus 48. 6 added together with minus 8 is minus 2. So factorising it, we've got y plus 6, y minus 8. I mean, you could have written y minus 8, y plus 6. That's fine, just reversing the brackets the other way around. But you've got to get these signs right. Now, once you've factorised, solving is easy. So we've just got this equaling 0. So y plus 6, y minus 8, just from here, equaling 0. Now, 0 times whatever is 0. So in turn, you've got to think what value of y would make this first bracket 0. Well, that's minus 6. Minus 6 adds 6 to 0. So when y is minus 6, this bracket is 0. 0 times whatever is 0. So our first solution is minus 6. Alternatively, what value of y would make this second bracket 0? Well, that's when y is 8, because 8 take away 8 is 0. Then 0 times whatever's in the first bracket would still be 0. So our second solution is 8. So you can see that our solutions, our roots, are the opposite signs to our magic numbers. Question 8. Now I'm going to start off by working out what this interior angle here is, which I'm going to call y. Once I know that, I can work out what x is. Now, this is a 10-sided polygon. Now, if you just come off from any point of your choice, going to all the other corners, you can see that a 10-sided shape creates 8 triangles. And the angles inside a triangle always add up to 180. So the total angles inside this 10-sided shape must be 8 lots of 180, which is 1440. So you can always just take the number of sides of a polygon and subtract 2 to work out the number of triangles, then times that by 180 to work out the total side of the interior angles. So we know all the angles inside this shape add up to 1440, and we know all of them apart from what I've called y. So adding all the other ones up, I get 1302. Subtract this from 1440, I can work out that y is 138. Now, angles about a point add up to 360, so x is going to be 360 take away whatever y is. So 360 take away 138, which is 222. Question 9. Now, whenever we have these percentage change questions, I like to just set up your 3 columns. So before the change itself and after, and always put your 100% in the before column. Now, we're told that the prices are reduced by 20%. So we're going to take 20 away from 100. 100 take away 20 is 80. Now, think about the multiplier. What would you multiply 100 by to get 80? Well, 80 divided by 100 is 0.8. So if we're trying to go from before to after, we would multiply by 0.8. Similarly, if we're going from after to before, we have to do the inverse. We would have to divide by 0.8. Now, on this particular question, we're told the price of the bag after the sale. So that 1080 goes in the after column. So to get the normal price, the original price, we're going to have to do 1080 divided by 0.8 equaling 1350. So always, step 1, work out your multiplier as if you were going left to right. Then step 2, decide whether you've got to multiply or divide by this. If you're going left to right, you multiply. If you're going right to left, you divide. So 1080 divided by 0.80 is 1350. Question 10, part A. Now the secret here is to break the 16 and b down to being 2 to the power of 4. 2 times 2 times 2 times 2 is 16. So I've just rewritten b as being 2 to the power of 4 times 3 to the power of 37. So your highest common factors, what common to both? You just need the highest common factor of the 2's, the highest common factors of the 3's. So the highest common factor of 2 and 2 to the power of 4 is 2. Highest common factor of 3 to the power of 43 and 3 to the power of 37 is 3 to the power of 37. Now for part B, again, it was all about just realising you've got to use 2 to the power of 4. So A times B is this A times this B, which I've written here. So multiplying the 2's, remember when you multiply, you add the powers. 2 is 2 to the power of 1, 1 and 4 is 5, so 2 to the power of 5. And again, adding the powers, 43 and 37 is 80. So it's 3 to the power of 80. So your final answer, 2 to the power of 5 times 3 to the power of 80. Question 11. Now the first thing to take on board here is we're told the trapezium is exactly one line of symmetry, which will be straight down the middle. So that means that this triangle on the end here and this triangle on this end here are similar. So the angles at the top would be the same. The angles at the bottom would be the same. Equally, this distance from here to here and here to here are going to be the same. Now, clearly, just dropping down a couple of perpendiculars, this length here is going to be 8.4 as well. And then we're splitting whatever 17.6 take away 8.4 is across these two lengths here. So I've done 17.6, take away 8.4 equals, that's 9.2. Divide that in half, so we've got our 4.6 and our 4.6. So I'm now just going to focus on this triangle here. And I know my base is 4.6. And I'm going to need to work out what this height is. Now, it's a trapezium. How do you work out the area of a trapezium? Step 1, you average the parallel sides. So my 8.4 and my 17.6. I'm going to add those together and halve it. Then multiply that by the distance between the two parallel sides, which I'm calling h. And that will give me the area, which this question tells me is 179.4. So from that, I can work out what h is. So I've worked out what this bracket is. That's 13. So 179.4 equals 13h. So h is 179.4 over 13, which is 13.8. So this height is 13.8, which I've gone and pulled out over here. Now, I'm being asked to work out what angle ABC is. So that's going to be whatever this internal angle in this triangle is here, A to B down to here, which I'm going to call X. And once I've worked out what X is, I will add that onto this 90 degrees to work out my final answer for angle A to B to C. So it's angle X here plus 90. So how to work out X looking at this right angle triangle? I'm going to use SOHCAHTOA. I know the opposite, I know the adjacent, so that will be tan. So tan X equals my opposite side of 4.6 divided by my adjacent side of 13.8. Inverse tan both sides, I get X equaling the inverse tan of 4.6 over 13.8, which is 18.43 ... So angle ABC is going to be 18.43 plus 90, which is 108.43 ... which is 108.4 to 1 decimal place. Question 12. Now to solve these, I'm going to have to what's called lining up. I'm going to have to line up either my x's or my y's. I need the same number of either x's or y's. Now I could have done it with my y's, but I'm going to choose to line up the x's. So 7x and 3x. So I want to get both of them to being 21x. So I'm going to multiply all the terms in number 1 by 3 to give me 21x. and all the terms in equation 2 by 7 to give me 21x again. So taking equation 1 and multiplying everything by 3, 3 lots of 7x is 21x, 3 lots of minus 2y is minus 6y, 3 lots of 34 is 102. Now I'm going to take equation 2 and multiply each term by 7. 3x times 7, 21x. 5y times 7, 35y, minus 3 times 7, minus 21. So I've achieved my first goal. I've lined up my x's. Now to eliminate them, I'm going to subtract my second equation from the top one. There's no point me adding them. 21x add 21x would be 42x. My x's haven't disappeared. No good to me at all. So I'm going to subtract one equation from the other. 21x take away 21x is nothing. That's the whole point. I've got rid of one of my variables. Minus 6y minus 35y. So minus 6 minus 35 is minus 41y. Now be careful over here. 102 take away minus 21. So 102 minus minus 21 is 102 add 21, which is 123. So minus 41y equal 123. Divide both sides by minus 41. I get y being minus 3. So that's my first answer. Now, to work out x, I take either of my original equations. I've taken the first one, equation 1. And now that you know what y is, you replace y with minus 3. So I'm replacing this y with minus 3. So 7x minus 2 lots of minus 3 equaling 34. Now minus 2 times minus 3 is plus 6. Then subtract 6 from both sides. Divide both sides by 7. I get x equaling 4. Question 13. Now this is quite quick if you're quite comfortable going from a compound interest rate to a multiplier. So you need to be aware that, say, a £5% compound interest rate would give you a multiplier of 1.05, and a 6% 1.06, say 5.5% 1.055. So if you're comfortable with that, you can do these quite quickly. So you take your principal amount, the 8,000, you multiply it by 1.0y to the power of 6. So I'm just using my variable here, which is going to turn into my interest rate a bit later, and because it's 6 years, it's to the power of 6, and then this is going to equal my total answer of 8877.62. So divide both sides by 8,000, I get this. Now to undo to the power of a 6, I'm going to multiply by the power of a sixth, 1 over 6. So multiplying both sides by to the power of 1 over 6, I get 1.0y equaling this to the power of a sixth. Putting that into my calculator on the right hand side, I get 1.017500022. So honing in on this bit, I can see what my compound rate of interest is going to be. It's going to be 1.75%. Okay, so that's the tricky bit, all right? 1.0y is 1.0175. So this is my compound interest rate, which is 1.75. Question 14. Now, these are pretty straightforward if you can just go through the various steps. So step 1, you want to create a provisional formula. So f is equaling something. F is inversely proportional to the square of v. Now, because it's inversely proportional, it's going to be k over something. Had it been directly proportional, it would have been k times something, where k is an unknown constant to be found. So f is inversely proportional to the square of v. This is the key line, f equals k over v squared. All right, if it had been f is inversely proportional to the square root of v, it would be f equals k over the square root of v. So this is just converting those words of the first sentence into a provisional formula. Now, step 2 is always going to be working out what the unknown constant k is from some more given information. And we're told when f equals 6.5, v is 4. So just substitute that in. F is 6.5, V is 4. So 6.5 equals K over 4 squared, so which is obviously K over 16. So to make K the subject, how do you undo dividing by 16? Multiply both sides by 16, so K is 104. So now we've now got our final formula, replacing K with what we know K is F now equals 104 over V squared. Question 15. Now, with spinner A, we can see we've got 2 reds and 3 greens. So the probability of a red is 2 out of 5. Probability of a green is 3 out of 5. Spinner B, we've got 4 out of 5 being red, 1 out of 5 being green. So the probability of a red spinner, 4 out of 5, green, 1 out of 5. And then just repeat it down here. 4 out of 5, 1 out of 5. Now, for part B, there's a quick way to do this. We're being asked to work out the probability that at least one of the spinners will land on green. Now, that's all the combinations, red-green, green-red, green-green, with the exception of red-red. Red-red is the only option where we don't end up with at least one green. So if we take the whole, because all probabilities add up to 1, and then just take away the one probability that we don't want, which is red-red, that will leave us with the probability of at least one green, so 1 or 2 greens. So what is the probability of red-red? Well, it's going along here, red, then red. So 2/5 and 4/5, and it's the probability of getting a red and then another red, so you multiply those probabilities together. Multiplying fractions is top times top, bottom times bottom. 2 4s are 8, 5 5s are 25. So 1 take away 8 over 25, while a whole is 25 over 25. 25 take away 8 is 17, so that's 17 over 25. Question 16, part A. Now, if you just picture this shape going from M to N to P to L, that's what's called a cyclic quadrilateral, okay? It's four-sided shape with each vertex, each corner landing on the circle. Now, one of the circle theory rules is that opposite angles add up to 180. So this angle at N, 58, added to this angle at L will add up to 180. So this angle here is going to be 180, take away 58, which is 122. And the reason for that is opposite angles in a cyclic quadrilateral add up to 180 degrees. Now, for part B, another of the circle theories is that the angle at the center is twice the angle at the circumference. So looking at it from the point of view of this shape here, MOPN, this angle which I've called X is going to be twice the angle at N. So 2 lots of 58, which is 116. Now we're being asked for the reflex angle MOP. So that's this angle here, which I've called Y, okay? Reflex being greater than 180. So once we know that X is 116, Y is going to be 366, take away that, which is 244. Now, there was a quicker way to do that. You could have looked at it from the other point of view, that starting off from here, that this angle at L, the 122, is going to be half the angle Y. So you could have just gone straight to the answer that Y, well, with what Y was, by doubling the 122, this bit in red. Now, with these bounds questions, I think it's quite nice just to do number lines to help you gather your thoughts. So I'm starting off with this 5 kilograms, which I'm immediately converting to grams, 5,000 grams. And that's correct to the nearest 50 grams. So going up to here, the next nearest 50 grams would be 5050. And going down, taking away 50, it would be 4950. So they're really my two goalposts. Now, if we then go halfway along between the centre and these goalposts, this set of points in yellow are all the points that are going to round down to 5,000, down to the 5 kilograms. So halfway along here is 4975, halfway along here is 5025. So then converting back into kilograms, my lower bound is 4.975, my upper bound is 5.025, and maintain that symmetry. Don't be tempted just to slightly adjust this one because we know this would in theory round up. We maintain the symmetry and we go with the 5025 or the 5.025 kilograms. Similarly with the volume, is 1.84 times 10 to the minus 3 correct to 3 sig figs. So my goalposts, you go up and down 1 sig fig. So 1.85 and 1.83. So my range of points that round to 1.84 times 10 to the minus 3 is from here to here. So my lower bound is 1.835, halfway between 1.83 and 1.84, and 1.845, halfway between 1.84 and 1.85. So lower bound, upper bound. So do that as a working. You're picking up method marks all the time by showing that you've worked out the lower bounds and the upper bounds. Now, density equals mass over volume, and we're being asked to work out the upper bound for density. So we want density to be as big as possible. Now, when you're dividing, to get the biggest possible number, you want the biggest number on top and the smallest number on the bottom. Okay, big divided by small is big. Imagine you win the lottery. You want to win loads of money, £10 million, and you want to be the only person winning it. So you want a big number on top, 10 million, and only you, the one person on the bottom. So big divided by small. So upper bound for mass, which is 5.025. Lower bound for volume, 1.835 times 10 to the minus 3. Pop that into your calculator, you get 2738.41 ... So to one decimal place, that's 2738.4. Now, with histogram questions, remember that the frequency, so the various totals, is represented by the area of each bar. Now, each of the bars are rectangles, so it's just basically areas of rectangles, base times heights equaling area. So the heights, okay, so for the first row, we're going from 10 to 20, so that's a range of 10. Then we're going from 20 to 35, so that's 15, 35 to 50 is 15, and so on. Now, it's a bit confusing this bit because whilst this is the heights column, from the point of view of thinking about the rectangles, those are actually the bases. Okay, so my base of my first triangle is going to be 10, going from 10 to 20. Sorry, my first rectangle, I'm going from 10 to 20. My second base is going to be going from 20 to 35. Third base, then 35 to 50, and so on. So those are the bases sorted. Now, the frequency, as I said, is the area. Now, we know with rectangles, base times height equals area. So going the other way, area divided by base will give me the heights of these rectangles. So 35 divided by 10 is 3.5. 45 divided by 15 is 3.0. So I get these various heights for the bars. I then choose a sensible scale. Now I've got to go up to 5. And if I just take these big squares, I'm going up to 6, so that's fine. So establish your heights and then just draw in your various bars. So my first one's got a base of 10, a height of 3.5. The second one, a base of 15, a height of 3, and so on. So those are my 5 blue rectangles there. Now, for part B, I'm being asked to work out an estimate for the number of these plants with a height greater than 40. So there's my line 40. So I want all the area to the right-hand side of that red line. So that's obviously going to include the 40 and the 8 that I've already worked out. Okay, the 40 and the 8 that were already given to me, that bar and that bar. The 40 and the 8. And I just need to work out this area here of going from 40 to 50. So base of 10, a height of 5, that's 50. So my total frequency will be the 50 plus the 40 plus the 8, which is 98. Question 19. Now, to rationalize the denominator, you've just got to learn that you choose to multiply top and bottom by this denominator, but with a change of sign. So multiply top and bottom by 3 plus root 7 for reasons you'll see in a minute. So that bit in purple is the key learning point. So we then do our expanding. 6 times 3 is 18. 6 times root 7 is 6 root 7. Now your 4 clause on the bottom. 3 times 3 is 9. 3 times plus root 7 is plus 3 root 7. Minus root 7 times 3 is minus 3 root 7. And the fourth clause, minus root 7 times plus root 7 is minus root 49, which is minus 7. Now, because we've got this change of sign, these two middle terms, the two terms containing the surds, will be equal and opposite, so will cancel out. So they've cancelled. We've no longer got square roots in the denominator. We're just left with 9 take away 7, which is 2. So 18 plus 6 root 7 over 2. Now each of these terms can be divided by 2. 18 divided by 2 is 9. 6 root 7 divided by 2 is 3 root 7. Question 20. So we're told that the area for R, surface area for R is 108, and the area for S is 300. So that's my area ratio for R and S. Now, you don't have to simplify these. You could just, because you've got your calculator, you could just do what we have to do without simplifying. But I think it's nice to simplify them if you can. So it's just dividing each of these by 3. So it's still an area ratio. I can get 108 divided by 3 is 36. And 300 divided by 3 is 100. So that's my simplified area ratio. Now, the key bit is how do you go from an area ratio to a length ratio? Now, area is 2-dimensional, length is 1-dimensional. So to go from area to length, you've got to square root. Okay, area to length, you square root. Square root of 36 is 6. Square root of 100 is 10. So that blue one there is my length ratio. And again, I can just simplify that, halve each of those. So I've got a revised simplified length ratio of 3 to 5. Now, how do we then go from length to volume? Well, that's going from 1-dimensional to 3-dimensional, so we have to cube. 3 cubed is 27, 5 cubed is 125. So to go from area to volume, it's a 2-step process. You square root to go back to length, you then cube to go to volume. So we've now got a ratio we can use, our volume ratio, because we're being asked to work out volume. Now we're told the volume of R is 135. So slot the 135 in your R column. And now it's just a question of proportion. What did we times 27 by to get 135? Well, do 135 divided by 27 and I get timesing by 5. So times this by 5 to get this. We're going to times this by 5 to get the volume of S. 125 times 5 is 625. Question 21. So when you've got to simplify these type of questions, there's going to be a lot of factorising involved. So I think the first thing to note is just to focus on this middle fraction where we can do some factorising. Now, if you look at the numerator, we've got a squared number take away a squared number. So you're just on the lookout for one of these difference between two squares. So the square root of 9x squared is 3x and the square root of 4 is 2. So you can factorize this to being 3x plus 2, 3x minus 2. Okay, 9x squared minus 4 is 3x squared plus 2, 3x minus 2. Now I'm now going to factorize this denominator, 3x squared minus 13x minus 10, which I've done over here as a side working. Now you may be able to just do this by trial and error and go straight to 3x plus 2x minus 5. I've got a slightly longer way of doing it. So my way is this. What two magic numbers multiply to be 3 times minus 10, which is minus 30, yet at the same time add to be the minus 13? Okay, multiplied minus 30, add minus 13, and that's minus 15 and 2. So we go from 3 terms to 4 terms, replacing the minus 13x with minus 15x and plus 2x. Doesn't matter which way around. So now go and fully factorise terms 1 and 2, and we get 3x minus 5, and fully factorise terms 3 and 4, we get 2 lots of x minus 5. And you might just have to mess around with this sign a bit to make sure that this is a repeated bracket. And then your final pair of brackets is the two components that aren't in the bracket, the 3x plus 2, and the repeated bracket, the x minus 5. So factorising the 3x squared minus 13x minus 10, we get 3x plus 2, x minus 5. Now that we've factorised here, there should be a lot of cancelling out we can do, and there is. The 3x minus 2 and the 3x minus 2 can cancel out, and so can the 3x plus 2 over the 3x plus 2, just leaving us with 1 over x minus 5 and the 7 over x minus 1 we haven't touched yet. Right, we now want to do this subtraction. When you're subtracting any fractions, you need that common denominator. Now, our common denominator is going to be x minus 5, x minus 1. So our first fraction, we're going to have to choose to multiply top and bottom by x minus 1. And our second fraction, we're going to multiply top and bottom by x minus 5, giving us this common denominator, so we can now convert it into just one fraction. So simplifying the numerator, we've got one lot of x and one lot of minus 1. And then be careful here, it's minus 7 times x, which is minus 7x, and minus 7 times minus 5, which is plus 35. Then simplify the numerator, minus 1 add 35 is 34, and x minus 7x is minus 6x. I've just popped them this way around because it's nice to have a positive term first, but you didn't have to. And then it was also then nice to do this extra step of factorising the numerator, because these are both even, to give you this, but you didn't have to. That would have given you full marks. Question 22. Now, I think a diagram really helps you gather your thoughts here. So we've got a rhombus, so that's obviously a parallelogram with equal lengths. And you don't necessarily need to label the A, B, C, and D yet. Do that once you've done the first bit of working. So our line 1, we've been told, goes through A and C. Points A and C both lie in a line, which I'm calling line 1, and that's got equation 2y plus 7x equals 20. So I'm calling this line y. Now, rearranging this into y equals mx plus c format, my 2y plus 7x equals 20, take away 7x from both sides, gives me 2y equals minus 7x plus 20, divide by 2, y equals minus 7 over 2x plus 10. So my line 1's got a gradient of minus 7 over 2. Now, I've therefore now just going to go and label my diagram. Because it's a minus gradient, it's going downhill, and this line 1 goes from A to C, so I'm making that my downhill one. So A to C, so I'm labeling it A, B, C, D. This is line 1 with a gradient of minus 7 over 2. Now, my gradient of my line 2 going from B to D, okay, is going to be perpendicular to that, because when you've got a rhombus, your two diagonal lines cross at a right angle. So as I know my gradient L1 is minus 7 over 2, my gradient for L2, flip it over and change the sign, is going to be 2 over 7. So I know my gradient of L2, 2 over 7, and I know it goes to the point 6 minus 11. So I can substitute that into my y minus y1 equals mx minus x1 formula. So it's y minus y1, so y minus minus 11, equaling my gradient 2/7, x minus x1, so x minus 6. Tidy this up, minusing a minus 11 is plus 11. Now at this point, I want to undo this dividing by 7, so I'm going to multiply through by 7. So multiplying my left-hand side by 7, I get 7y plus 77, so that undoes the 7 on the right. And then I'm just going to do the claw. 2 times x is 2x, 2 times minus 6 is minus 12. So that is an equation for my line 2. I mean, I could have gone and tidied that up, but I've just decided to use it as is. Now, where does it meet the x-axis, y-axis, excuse me? Where does that line running through B and D meet the y-axis? That's when x equals 0. So I'm just going to substitute x being 0 into this, and that gives me 7y equaling minus 89. So divide by 7, my y coordinate is minus 89 over 7. So the coordinate where it meets the y-axis is 0 minus 89 over 7. Looking at it again, it might have been simpler if at this point here I just added 12 to both sides, having 7y plus 89 equal 2x, but it didn't matter. At the end of the day, you get an equation for L2. It meets the y-axis where x equals 0, so substitute x being 0 into this to give you the y value. Question 23. Now, we want the range of values where the gradient of c is negative. So when you differentiate it, you want the set of points which is less than 0. So differentiating this, I get dy dx equals 3px squared minus m. Remember, you multiply by the current power, so that's 3, reduce the power by 1. So that first term becomes 3px squared, and minus mx will become minus m. And we want the set of values where this is less than 0, because we want the set of value as the gradient is negative. So rearranging this, I'm adding m to both sides, then dividing by 3p. So I want the range of values for x squared, which is less than m over 3p, this constant m over 3p. Now my roots, when I go and square root this, is going to be plus or minus root m over 3p. Right, go and square root this. If you just think of x squared equaling m over 3p, my roots, when I square root both sides, are going to be plus or minus root m over 3p. So I'm just going to do a little sketch to help me gather my thoughts, okay? So here's my curve y equals x squared. Here's my straight line y equaling m over 3p. And my two solutions are minus root m over 3p and root m over 3p. And I want the set of values where the curve is under the line. The curve is under the line, this set of values here. So this is where x is less than root m over 3p, but greater than minus m over 3p. Question 24. So they give me the arithmetic sequence, so I can see my first term a is 8, and I can see that my common difference, I'm going up in 7, so d is 7. Now I want to work out the sum from the 50th term to the 100th term inclusive. So I want the 50th term, I want the 100th term. So the key bit here is to realise to work this out, you're going to work out the sum of the first 100 terms and take away from this the sum of the first 49 terms. That will leave me with the sum from the 50th to the 100th inclusive. So I'm then just going to substitute in twice into the sum to nth term formula, which I'm given at the front, which is this. So my sum for the first 100 terms, so n is 100, is going to be 100 over 2, 2 lots of a, 2 lots of 8, plus 100n minus 1 times my common difference is 7. Popping that into my calculator, I can see that the sum of the first 100 terms is 35,450. And repeating for the sum of the first 49 terms, so exactly the same, but on this occasion n is 49, 49 and 49, but a is still 8, d is still 7. I get the sum of the first 49, it's 8624. So my sum of from the 50th to the 100th is just one of these take away the other, 1 take away 2, which is 26,826. Question 25. Now, whenever you've got the change outside the function, this affects the y values exactly as you would expect. So the y values are going to go from say plus 3 to minus 3. The y value is going from 5 to minus 5. So just visualize that. The y values are changing, so that's a reflection in the x-axis. Now, for part B, similar idea. The 2 is outside the bracket, so that does, as you would expect, the y coordinate. So we're going to be doubling all the y coordinates. Anything inside the function, inside the bracket, affects the x coordinates opposite to what you would expect. So we're going to be adding 1 to all the x coordinates. So I'm just going to go along all the key points on the curve I've been given and making sure that I double the y coordinates and I add 1 to the x coordinates. So 1, 3 becomes 2, 6, 2, 0 becomes 3, 0, and so on. So I've taken the 7 key points here, and I've just doubled the y coordinate and I've added 1 to the x coordinates, and I've plotted those to give you that curve there. Sorry, my curve's a bit wobbly. It's quite hard to do on my computer at home. It's a lot easier to do when I've got the big board at school. So that should be a gentle curve there.